Hello, I'm Dan Olds on behalf of Hyperion Research and Inside HPC. And today I'm talking to Michael Resh, who is honorable professor at the HPC Center in Stuttgart, Germany. How are you, Michael?
I'm fine, Dan. Thanks.
Very nice to talk to you. And I guess let's start at the beginning. How did you get involved in HPC in the first place?
Well, that started when I was a math student and I was invited to work as a student research assistant. And by accident, that was roughly the month when a new supercomputing was coming to the Technical University of Graz. So I put my hands on that machine and I never went away again.
You sort of made that machine yours, I guess.
We were 3 users only. So there were 3 user groups, and I was the most important user of my user group because I did all the programming.
Fantastic. That's a way to make yourself indispensable, isn't it? So,
in a sense,
can you kind of summarize your HPC background over the years?
well, I started doing blood flow simulations. So I first looked into this very traditional Navier-Stokes equations that was driving HPC for a long time, and then moved on to groundwater flow simulations, pollution of groundwater, tunnel construction work, and everything. Until after like 5 years, I moved to the University of Stuttgart, where I started to work with supercomputers, more focusing now on the programming side, the performance side, and also on the hardware side. So this is sort of my background in terms of experience. In terms of education, I studied a mixture of mathematics, computer science, and economics, and then did a PhD in engineering, which was convenient if you're working in Navier-Stokes equations.
I'm sure.
So I try to bring all of these things together to make an impact in HPC.
So what are some of the biggest changes you've seen in HPC over your career?
Well, the biggest change, the biggest change is probably that when I started, as I said, there were like 3 user groups. And these were outstanding experts in their field, and supercomputing was nothing for the rest of the university. Today, everybody is using HPC. So that's probably the biggest change, that we are moving from something where you have one big system and a few experts around that system. You move to a larger number of systems and tens of thousands of experts working with that.
And so the systems have to get bigger, of course.
Well, certainly they have to get bigger, and they have to get, I would say, more usable. So that's another feature that now things are more hidden from the user, which makes it easier to use them, but at the same time takes away some of the performance. And there is this combination of hiding things away from the user, and then the massive parallelism that we saw, and that's the second most important thing that I think we saw over the last 3 decades. That has made it much more difficult to get sustained performance.
Okay. So where do you see HPC headed in the future? Is there anything that has you particularly excited or concerned?
I'm always excited and concerned, so that's just normal. That's what happens when you go to science, and that's normal when you work with supercomputers. I see basically 2 things happening. The first thing is that you merge everything that has to do with data and everything that has to do with simulation. So I keep saying it's data analytics, machine learning, artificial intelligence, sort of a development from raw data to very intelligent handling of data, and these things start to merge with simulation. Like we see people trying to understand what they did over the last 20 years by employing artificial intelligence, working its way through the data, trying to find out what have we already done, what should we do next, things like that. Yeah. And the second thing that is exciting is quantum computing. It's exciting because it's out of the ordinary in a sense. Yeah?
Yes.
You might say that over the last 32 years, the only thing I did was work with improved technology and improved methods and improved algorithms whatsoever, but I was still working in the same John von Neumann architecture concept.
Yes.
Now, going to quantum computing, we have to throw away everything and we have to start anew. And this is a great time. And I keep telling my PhD candidates, go for quantum computing. This is where you make an impact. This is where you have a wide open field of things you can explore. And this is what is going to make the job exciting for the next 10, 12, 15 years or so.
That's fantastic. And your enthusiasm for this really comes through. Your enthusiasm for HPC, for the new computing methods and all of that. And thank you so much for taking the time.
It was a pleasure. Thank you.
Thank you. Really appreciate it.
Okay. Bye-bye.
Bye-bye.